In this next video, I'm going to introduce you to the first of two different nonparametric tests that you're going to learn this week. This first test is called the goodness of fit test. And in this video, I'm going to help you to understand the logic of the test and some factors to consider when using what we're going to call a chi-square. So why do we use a nonparametric test again? Well, remember, sometimes our scores violate the assumptions of a parametric test. Maybe our data are non-normal and we have a low n. Or maybe the unit of measurement prevents us from using the mean or standard deviation. Maybe it's nominal or ordinal data. So maybe we're not using numerical data, in other words. And then for ease and convenience, nonparametric tests are pretty simple, as you'll see. So let's say you're hired as a statistician by a disgruntled employee who says that the company discriminates on the basis of gender. And this is the employee's evidence. There are 10 managers, 6 are men and 4 are women. We can do a chi-square analysis to find out if this represents a real difference or if this is just random chance that we have 6 men and 4 women. So what would we expect the population of men and women to look like? Well, if we are saying that there's an equal chance, then that would be 50 and 50-50. So if we have 10 managers altogether, that would be 5 in each group. But what our observed sample looked like was 60-40, or 6 in one group and 4 in the other group. So what we're doing when we're doing a goodness of fit test is we're going to come up with something called a chi-square statistic that's going to let us know if what we're observing in our sample is much different than what we would expect to see if all things were equal. So in this case, here's the breakdown of males and females. And as you can notice that on the right-hand side, we just have one extra male. And so if you were to do a chi-square analysis on this, it would say this is just random chance. It's not something that means anything statistically. But the disgruntled employee will not give up and wants to collect data on 100 managers. So we would still expect, if all things were equal, there to be a 50-50 split. And this picture represents a 50-50 split between males and females. But this is the actual observed data when you took 100 managers. We had that proportion at the top of males and the proportion on the bottom of females. So what about now? What would you say now? Is there a disproportionate representation of males to females? So there does seem to be some gender differences when you split it out amongst 100 managers. A 60-40 split becomes significant. It's probably not just related to chance or luck at this point. So if you contrast this with the 10 manager example, that was only a difference of one person, and that can happen. It could have been related to chance. So this example shows that sample size is really important when we're doing our chi-square statistics. Statistically significant differences are more likely to show up when we have a larger sample size. So this last example asks questions about proportions in the population. So as you'll notice, individuals don't have scores, but they're classified into categories, and the number in those categories are counted. And then proportions of the population are evaluated and compared. In the next video, I'm going to talk with you about how do we write hypotheses for goodness of fit tests.